Did you hear that? Do you ever wonder what they're saying to each other? Communicating in languages that are possibly the most foreign to our own, right outside your window. If that's possible right outside your window, then what's going on in processes that we cannot hear or see? Systems that are constantly working to produce their own energy, food, and macromolecules. As life goes on, it becomes easier and easier to disregard your surroundings. The ancient practices of plants and animals can aid in revealing the tapestry that Mother Nature has woven us into. Now, it's okay to not understand every molecular and atomic interaction, or even the human and animal activity happening 360 degrees around you. But, faced with notions of complex understanding, I would say look, it's right in front of you. Before we observe some processes that we can't see, understanding the behaviors of animals in our own homes might be able to help us understand how complex everything is around us.
Human growth's fascinating. In utero, obviously, the rate of growth is interesting because you've got 9 months to grow from a fertilized egg all the way into a little 7 or 8 pound human when you're born. And then once children are born, they time out their growth rate, like at by 1 year this should happen, by 2 years this should happen, and then everyone grows at an individualized rate. And I think it's kind of cool because you really never know by the time you're 18 or 19 how big you're going to get and what your size will be, but you will grow. As far as dogs or pets go, they have interesting growth rates too. And since I became a dog owner a year ago, I had no idea that their time in life is like 7 times human life. So my dog in particular is full grown now. So he started out as like a little guy, and now he's 25 pounds. And obviously his personality is, I would say, fully developed. He's kind of crazy but super loving. And so even though he's 1 year old in dog years, he's really 7 to 15. And since he's a little dog, they say that they grow a little bit faster. So he is a full size little doodle now. Told that they settle down and that they age just like humans do, and that they act calmer. But time will tell on that. I mean, they should, but I'm sure some dogs are more hyper and more pets are different, than other pets.
Maxie and Tazzy have very big personalities. Taz is very loving and he just wants to be all up on you all the time. And Maxie is very like energetic and I don't know, he loves attention. He likes to be the only one given attention or else he gets jealous. Max knows how to sit, lay, shake. He knows how to play dead, which is crazy. And he knows how to like find treats if I hide them. He knows how to go in between my legs and sit down. I think that's all he knows.
He's very anxious, but calm whenever he's around people he knows, like my family. And also, he's very loving. When you come in the door, he always like jumps up, or not jumps up, but he always greets you and is very excited and wagging his tail. And also, he's very curious. Whenever he's on a leash, like he's off sniffing everything.
Gentle.
Give me a face. No, don't move.
I think he would be like a little kid. And he would be all over the place and like just saying whatever. I think he would have no filter.
If he just had free reign in the house, he'd probably get into the cupboard first and get into all the food. And then he'd sit outside on the porch for like hours. Bang! Bang! Bang!
Now that we've looked at some of our companions in the animal kingdom, our rooted relatives can offer up their fair share of intricacies.
Plant life cycles are different, so all plants will require sunlight and food like fertilizer and water. And plants, just like humans, everything has like a predetermined growth, like the max they can grow to. And obviously a plant life cycle is a lot shorter than a human or an animal life cycle. Photosynthesis is continuous, whether it's light or dark. There will be sugar or glucose, C6H12O6, produced as food. as well as oxygen released as well. So we benefit from that as humans, of course.
A single leaf can absorb more than 10 quadrillion photons each second. The energy from those photons powers photosynthesis, maintaining the oxygen you breathe and manufacturing food and fuel for the living biomass of our planet. You know, there's a whole nother world beneath our fingertips, in the cells of our skin, and actually, everywhere you look. At this point, certainty turns into theory. Without being able to see the engagements between the elements of our universe, it gets a little dicey. But the interactions observed beyond the molecular level might just be the ones that carry the most insight on activity around the globe.
Cellular respiration is going to be the O2 that we breathe in, and then it goes into our lungs and it circulates through there, goes through the body, and then what we release is going to be the CO2 for that. So then the plants use the CO2 in their respiration cycle. Redox is a complete transfer of electrons. If we're doing like our electrochemical cells, so I have all this set up right there. So you have a solution, and then you'll have a metal, and you can literally see the transfer of electrons, because the copper will fall out of solution and become your red copper and then your metal will slowly disintegrate. But in like batteries and things like that, we come up with systems where we have all those chemicals wrapped up in a nice little battery, and then as soon as we put it into our electronic device, the reaction starts happening, and then the movement of the electrons allows us to power the electronic devices, or for like recharging your phone.
Yeah.
That we definitely don't have. So you take that system that naturally occurs and naturally wants to transfer electrons based on like the strength of the atoms, and reverses it and makes it go the opposite way, so it gives the electrons back. And like a lot of the renewable resources are relying on electrochemical cells to generate that electricity, like hybrid cars. That's a big one. I hate doing blanket statements, but I think I'm right here. All of your combustion reactions, so anything reacting, like anytime you light the candle, it burns on its own. It's a redox reaction. Once the vaccines go in, they work on different pathways, whether it's like mostly IgG for the immune system, but it's gonna work more on the surface level proteins. So a lot of your biochemistry again ties in there. So it recognizes different like functional groups and can attach to those on the virus and then work on degrading the virus through very like atomic and molecular level chemical means. So it's not just gonna be one chemical. Big issue, if I can sidetrack a little bit, with like vaccines and some people's beliefs are that it's actually the chemicals that vaccines were stored in. Some of them believe that those cause, brain development issues. As far as I'm aware, there's always going to be side effects in anything that we ingest. I mean, even oxygen's slowly killing us. It's literally oxidizing us. That's oxygen, but carbon's so cool because it can form the 4 different bonds. So that allows it to make these ring structures that created what the majority of chemistry is in this field, is organic and bio. It's all because of the carbon. So then the carbon, if it's attached to like an oxygen and then a hydrogen, that can be, and depending on what the rest of the chain is, that can be an alcohol or, blanking now, an alcohol or, anyway, let's just go with that. That's an alcohol functional group. So your proteins in your bodies are amino acids. So they're gonna have the same structure, but again, depending on the little functional group, that'll be different. And I believe those are huge in contributing to the active sites and being able to have your body create systems and pathways that recognize those functional groups and cause the cascades for certain things. And that's why when you have autoimmune diseases, it's a lot of messed up chemistry in your body of those functional sites. Atomic level alterations that cause huge macroscopic level issues because they can't recognize or they can't initiate a cascade or a response because of a carbon or an oxygen not being in the right place or too many of them being there.
Ready? Bang!